and thank you for having me here today, and good day, everybody. Today we're going to be talking about PolarFire SoC and the iSchool kit. We'll talk a little bit about PolarFire SoC. What is PolarFire SoC? The iSchool kit you can buy today, and development tools and the Mi5 ecosystem. Okay. So PolarFire SoC is a SoC FPGA built on top of the low power PolarFire FPGA architecture with an integrated processor subsystem. Everything in the gray boxes is a hard processor subsystem, okay, with full I/O, memory switches, L2 memory subsystem, memory controllers, and DDR5. The CPUs we purchased with our Mi5 partner, SiFive. We have a very good relationship with SiFive and a strategic relationship with SiFive. These cores are the application cores are the U54 Freedom Unleashed cores, and the monitor core is the E51, although I think now they call that the S2. I'm not 100% sure. So PolarFire SoC is an SoC FPGA that's very power efficient. Okay, it has some unique AMP modes for mixed criticality systems. I can run Linux in real time on the CPU cluster all at once. We've built in defense grade security. Okay, and we're exceptionally reliable. Our products are used everywhere from ground level up to space and beyond, even Mars. Okay, and I'm very happy today to let you know this is like the first mass market RISC-V product that you can buy in any kind of quantity 1 or quantity 1 million. Okay, the products that we make are very low power. Okay, we want to get rid of fans because fans break. They will break your system. Heat sinks cost money. Fans cost money. So we benchmarked PolarFire, for instance, this device right here, MPFS 095, compared to dual Cortex A9 SoC FPGA, another dual Cortex A9 SoC FPGA, and a dual Cortex A53 SoC FPGA. All these devices are equivalent in size to PolarFire SoC, roughly 100,000 logic elements. And what we're benchmarking here is not the FPGA performance, but the processor performance. So we're benchmarking using core marks. We're measuring core marks delivered and how much power is consumed for each device. And as you can see, PolarFire SoC is the lowest power device on this chart. The lowest power device from our competitor consumes almost 1.3 watts without performing any kind of computation. Okay, so if you have a power budget, that's only a couple of watts for your application, you can't use anybody else's product. You'd have to use PolarFire SoC. Or, if you have a performance requirement, say of 8,000 core marks, and you have to deliver 8,000 core marks in less than 1.5 watts, or less than 2 watts, or maybe less than 3 watts, there's really no other product you can do. So we've optimized PolarFire SoC to be very power efficient for a variety of applications. This is the iSchool kit. It's very simple to use. When you purchase this iSchool kit, to set it up and see Linux running, you just have to connect power here and connect a USB terminal over here. Okay, configure USB terminals and flip the switch. I'll show you some slides on what happens on that. But it's a very small form factor, low cost board. It's got Raspberry Pi hat connectivity over here. It's got microbus clip connections capability here, and it's got a PCI Express connector here. 2 Ethernet ports. There's an onboard 8 GB embedded NAND flash to store your Linux image. There's also an SD card for expansion and numerous, buttons and LEDs. Okay, so PolarFire SoC boots from the system controller, and there's startup code in the ENVM called Hart Software Services. Okay, the Hart Software Services will configure the processor subsystem and start the boot process. All right, so to set up the kit, you plug in power, connect USB port here, configure COM0 and COM1 to 115 kbaud, and turn on the switch. And what you'll see is in COM0, you'll see the Hart Software Services execute, and it'll sit there into a wait loop and time out. After it times out, it will start loading U-boot. Okay, it'll grab U-boot from the eMMC flash and copy it out into external DDR memory and start executing. Okay, and you can see that command there. All right, and once it does that, it starts booting Linux. Okay, and you can see it going through the boot processing, grabbing the image, running until you get to a root prompt, and you have Linux. So, in less than 2 or 3 minutes, you can get a fairly, nice out-of-the-box experience. Doesn't take much to get Linux up and running on this kit. It's shipped that way. So, what do you do once you have a kit and you've booted it up and you've got Linux running? Well, you can start developing applications. All of our application examples for both bare metal, a Yocto Linux recipe project, a build root recipe project, are all located on PolarFire SoC's GitHub. And to find it, you just Google PolarFire SoC GitHub, and you'll find the repo. Okay, all our documentation is up there. The Hart Software Services is up there. In this bare metal repository here, we have application examples for all the peripherals. So using the ASCII kit in the GitHub repo, you can easily get up and running and start evaluating, the benefits of RISC-V, PolarFire SoC, all in one. There's also a new website being created by the RISC-V Foundation called the RISC-V Exchange, and the RISC-V Exchange is designed to, bring all, everything together, kind of like in a marketplace. Excuse me. Where you can have boards, cores, SoCs, IPs, documentation, books, things of that nature. So that's up and running. And then part of that RISC-V Exchange is a discourse site. So we have a discourse site where you can discuss and share ideas for the Yocto project, the build root project, the bare metal projects. How to take the iSchool kit to factory defaults in case you program it with the wrong image, a form for Hart Software Services and a general form. So this just became live. So if you have questions about the iSchool kit, you can post questions there. This will be moderated by microchip engineers to answer your questions in a timely manner. Okay. Also, to help you out on the Icicle kit and PolarFire SoC to learn how to do new things quickly is, Microchip has a YouTube channel, and there's a section in our YouTube channel called Field Programmable Gate Arrays. And here you can find various playlists. This playlist will show you how to debug a bare metal application, and it consists of 3 videos. Each video is 3 to 5 minutes long. It's very short. Okay, so three to 5 minute videos. The next one would be, how do I do bare metal applications and execute that code from the loosely integrated memory on PolarFire SoC. And the next one is, how do I build a Actel image and control something in the FPGA fabric? So we have 3 videos out there now. There'll be 3 more by the end of the month, all designed to walk you through the process of, taking the box, opening the box up for the Icicle kit, doing some very simple hello world debug using the Actel kit, and then using the various features of PolarFire SoC and building up your knowledge of how to design with PolarFire SoC. So we'll have 6 up by the end of November, and we'll keep adding new playlists every month as we move forward in time. We also have system on modules from various companies that are available. Aries Embedded makes a system on module with PolarFire SoC. You can see the form factor there. Trends has a system on module. Digital Core has a system on module with a Wi-Fi Bluetooth module built in. Sundance DSP has a system on module and carrier cards, and this is available on Crowd Supply. And then there's a crowd-funded effort by Ali Uzul on Crowd Supply to create a very high-end board called Savvy-V. So very soon you'll have the capability to purchase various different form factors to try out PolarFire SoC. Okay. We have a whole list of Mi-5 ecosystem partners. We have Sci-Fi for the CPU cores. Wind River has VxWorks BSP for the Icicle kit. Mentor has a BSP for the Nucleus operating system. DornerWorks has ported SEL4, a formally verified microkernel running on the Icicle kit. Mdalo Technologies is a embedded design partner with deep Linux expertise. HexFies adds a multi-zone security capability to PolarFire SoC. Wolf SSL has crypto libraries running on PolarFire SoC. IAR Systems will support PolarFire SoC in the first quarter of next year with 64-bit RISC-V support. We'll have Amazon FreeRTOS. We'll have a Zephyr port coming soon, and more Mi-5 partners are joining the Mi-5 ecosystem as they get hands on boards and starts developing with them. Okay, so where to buy? You can buy the Icicle kit at Crowd Supply. You can buy it at Mauser. You can buy it at DigiKey. You can buy it at Arrow, and you can buy it at Avnet. Okay, we've built 1,000 boards. We've sold 700. We're building 1,000 more. So they're very popular. They're being bought as soon as we can make them, and we'll just keep making more to satisfy the demand. So it's a very low-cost way to get access to commercialized, production-worthy, RISC-V technology. Okay. And just to summarize, PolarFire SoC is an award-winning mid-range FPGA platform. 30 to 50% lower power, defense-grade security. We have the best security in the FPGA in the world. We have exceptional reliability. Our parts are not subject to some of the radiation effects that some SRAM-based products are subject to. And so PolarFire SoC adds a very cool processor subsystem to it. It's RISC-V based, and where we can do Linux in real time in a deterministic coherent CPU cluster. Learn one architecture, PolarFire SoC, and develop applications for Linux, develop applications for bare metal, or develop applications for mixed criticality systems where you have to have Linux and some hard real-time function running side by side. Okay, so you learn one tool, create many different applications. Okay, and it inherits the power-saving features of PolarFire and the security of PolarFire. We've got defense-grade secure boot, side channel resistant. Can't steal keys by measuring power. And the CPUs that we chose from Sci-Fi are relatively simple, 5-stage in order machines that are Spectre and meltdown immune. Okay, and to increase the reliability of the chip as a whole, all the memories in the processor subsystem are single error corrected and double error detected, and a majority of them are actually interleaved to prevent multi-bit upsets. So some important links to kind of leave you with is our website for PolarFire SoC. We have solutions, getting started, documentation on the iSchool kit. We have a tool called the MSS configurator that allows you to configure all the control and status registers in the processor subsystem, graphically. We have the FPGA software, and we have the soft console, Eclipse-based IDE development environment. You can contact folks in marketing at this email address. Tech support is our default portal here. As I mentioned earlier, you can go to the Discourse site, and we have videos being posted up on the Microchip YouTube channel. Okay, so I want to thank you for your time today. I think that was about a 20-minute pitch. If there's any questions anybody wants to ask, please do.
Thank you very much, Tim. There is one question from audience now. So,
okay.
So, can the FPGA board provide display output?
So it's a good question. There's two avenues for that. One of them is Antmicro makes an HDMI converter that connects to the Raspberry Pi hat that's on the top of the board. If I go back, if I go back to this slide here, Antmicro has an HDMI adapter that plugs in here. Okay, that's one way. The other way is we do plan on the future having a smart LCD display to connect to the Raspberry Pi hat connector. Okay.
Thank you. And another question: are there any simulation tool for co-verifications among RISC-V software and FPGA logic, including real-time interrupt handling?
So we have a tool called Renode. Again, it was created by a company called Antmicro. They've created a virtual model of the PolarFire SoC processor subsystem. It's a functional model. It's not a timing accurate model. But one of the things you can do from a chip level kind of software verification environment is you can take Verilog that you have in the FPGA, run it through Verilator, and integrate that into the Renode flow as a model and do, an entire chip level software type debug. Now, there is, we just recently acquired a company called Leg Up for doing some high-level synthesis. And high-level synthesis is, primarily converting C or C++ to Verilog. And as we roll that tool out next year, we'll be creating a verification environment and a simulation environment for that flow. So it'll be high-level synthesis to RTL, map the RTL to the FPGA, run the rest of your C code in the processor subsystem. Okay.
So you said next year. So early next year or
mid next year for that flow. Today we can do simulation of the FPGA portion using our standard FPGA simulation tools.
Okay, thank you very much. And is there any another question from audience? So if you have question, you can write in Japanese or English to the Slack channel and also Twitter.
Okay.
Okay. Yeah. Thank you so much.
Okay. Thank you very much, everyone.